Good morning, good afternoon. Thank you very much for being here with us. I am in good company. I am the company of Professor Dr. Sergei Miller of the University of Twente in the Netherlands. My name is Mauricio Pradena from the University of Concepción in Chile. And together we will share with you a little bit about the Twente educational model and its application in Latin America. And one of the applications has been in the University of Concepción, so that is the reason because also I will share part of my experience. Thank you very much, Professor Miller, and I would like to tell you a little bit about the International Summer School for Professional Training of the Perderse Foundation. It's a very important event in Latin America because we can reach different professors, lecturers in all Latin America with different realities, different possibilities in more rural areas, urban areas, and it's very important that we can reach them with this knowledge. So thank you very much also for sharing your knowledge.
Yeah, you're welcome, Mauricio. Thanks very much for inviting me to have a chat with you.
Great, thank you. So we will go in order of the time. We will go immediately to the topics that we have for this opportunity. First, I would like that you can share with us about an overview of the University of Twente.
Okay. Yes, the University of Twente is one of 4 technical universities in the Netherlands. I think most people are familiar with some of the more famous universities in the Netherlands. We are situated in the east of the Netherlands, University of Twente. It's quite a young university, having been started in the 1960s. The university offers engineering programs, civil engineering, electrical engineering, mechanical engineering, industrial engineering, and then, of course, technical medicine, a number of technical programs. We have about 12,000 students at the university, and the university is growing. Most of the bachelor programs are conducted in English. We changed from Dutch to English a few years ago. Mauricio, can you pause this? Are you able to edit it afterward? So the University of Twente has about 12,000 students, and we have about 3,500 staff members. Like other universities in the Netherlands, we are a research-based university with several research programs. I myself am involved in asphalt process control, and so I do lots of work with many construction companies here in the Netherlands. And it's typical for the university to be working closely with industry.
Great. Thank you. Thank you very much for that introduction. Well, now we go from that introduction, to the main topic of this presentation. That is the Twente educational model. What is the Twente educational model? What are the main characteristics of this model? Could you share with us?
Yes, of course. Just to share with you that let me start by saying that the Twente education model is not a traditional teaching model as you would find at most universities. So most universities, civil engineering programs, you'd have a first and a second year that would cover basic skills and competencies relating to mathematics, physics, chemistry, etc. The Twente education model is based on a problem-based or project-based learning model where we offer, during the bachelor program, we offer 12 themes, and those themes are used to teach towards. So in other words, every module has a project, and we teach towards that project. So we teach mathematics, structural mechanics, soil mechanics, etc., and we teach towards the needs of those projects. So what that actually means is that we try to get an actual project, a real world project, and we try to get our students to interact with that real world project. So I'll just give you an example. So in module 1, which is an introductory module on the civil engineering program, we have a cooperation agreement with the local municipality, the municipality in our city, which is the municipality of Enschede. So we sit down every year in preparation for the new academic year. We sit down with the city engineer or somebody from the city engineer's office, and we find out whether the city has any problems that our students could try to find a solution for. So that problem could be the redevelopment of an intersection, the redesign of a cycling path, the redesign of a portion of a road experiencing. We then let our students loose on that design problem, and they have to design a solution or redesign the solution. What that means is that we divide our students up into groups of about 5 or 6 students, and in total we probably have about 18 to 20 groups, and each group will approach the design problem and design a solution. They have about 10 weeks to do this, right? And most of them complain because the problem is pretty open-ended. We're not very prescriptive about the solution. The students have to do a conceptual design. They interact with us as representatives of the municipality. So we act as the client. Myself and my colleagues, we're about 5 colleagues who teach in this module. So the students have deliverables every 2 weeks. We interact with them in terms of looking at the deliverable, whether it meets the requirements of the client, and giving them guidance. Just to tell you that there are several things that are unique to this problem-based learning approach is that, number one, we try to have open-ended problems where there's not one design solution. There might be several solutions possible for the project. Number two, we don't give students all the skills and all the information that they need for the project. So obviously we're teaching mathematics, we're teaching construction materials, we're teaching structural mechanics, soil mechanics, we're teaching concrete mix design, for example, and they have to use that in their design project. But what we don't teach them and we don't give them is, for example, specifications. The students have to find the specifications on their own. What we also don't give them, we don't teach them is, for example, how to use Revit, AutoCAD, how to use InfraWorks, how to use Google SketchUp. So they've got to produce digital drawings, but we don't teach them how to use the software. So they have to decide in their groups which software is appropriate for them to use, and they basically have to decide who in the group is going to take responsibility for their drawings. So this very uncomfortable situation makes it very, very difficult for them, and they complain a lot during the first 2-3 weeks of the project, in that we're not giving them enough information, we're not teaching them how to use certain tools, etc. But of course, we then explain to them the reasons behind this, in that we're trying to mirror what is happening in the world, we're trying to mirror what is happening in real life, and that they have to be able to deal with what we call wicked problems, open-ended problems. Our experience is that at the end of the 10 weeks, at the end of a typical module, the feedback that we get from students is very positive, in that students say that they've learned a hell of a lot, and that the experience has been a positive experience. Of course, there are lots of challenges that we have to deal with. and perhaps I can tell you about some of the challenges later on.
Great. Thank you very much. Very complete, the description of the model. I can hear my colleagues in Latin America asking questions regarding to this. For instance, you said that you teach certain topics. So the project is leading the education. At first, you have some modules like our traditional lectures. That is one. And the second one, the evaluation. I can hear my colleagues in Latin America asking, and how do they evaluate this?
Okay, so that's a very good question, because you have knowledge that you're trying, so you have fundamental knowledge that you're trying to get across. So you have mathematics, you have construction materials, you have structural mechanics, you have something that you're very familiar with, concrete mix design. The question is, how do you test whether students understand those fundamental courses? So those fundamental courses, we still have tests and we still have exams for those fundamental courses. So mathematics would still have a traditional examination. They might have some tests in the run-up to the exam at the end of the module. Structural mechanics will have some tests in the run-up to the exam at the end of the... So we haven't done away with that. The project, how we assess the project, is linked to all of the courses, but the project we assess on its own. So what we do is there are, say, 6 deliverables, and each of those deliverables will count towards a final project mark, a project grade. And those deliverables are assessed either with a green or no green. In other words, when they deliver their conceptual design or their conceptual solution, all right, we don't give them a grade for that concept solution. We give them a green or a no green. We say, yes, it's good enough, you can continue, or a no green means, no, you have to redo it, all right, before you can continue. So they can only move on to the following deliverable if there's a green, all right. At the end of the project, at the end of the 10 weeks, we then grade each and every element. So we grade the concrete element, we grade the road design element, we grade the water design element within the project, if those are the design elements, all right. And we then give them a final grade based on the summation of all those separate deliverables. All right. So there is a role for exams. All right. We have examinations to test whether the students understand the fundamentals. All right. But what we're trying to see in the project is whether they're able to apply what they've learned in an actual design setting, an actual project setting. All right. And we're doing this repetitively. We're doing it every module. There's a project in every module, and the learning is then centered around this project. The learning needs to be applied within the project, but we're also testing the fundamental competencies and the skills that they're building up in terms of mathematics, in terms of a mathematics line, in terms of a structural mechanics line, in terms of a materials line, etc., etc. All right. But they're constantly applying what they've learned in the project, constantly applying what they've learned. And so we're trying to stretch and challenge them in the project, all right, to make sure that they're thinking about the right things. Am I using the right specifications? Am I applying it in the right way? Am I finding the right information? Am I communicating? Am I communicating in the right way? So part of the project at the end is that they have to defend their projects. So we set up for each and every group, we have an hour-long defense, okay, where they present their project, and we grill them for almost, they present for about 15 minutes, and we grill them for 45 minutes. Okay, so why have you chosen this design approach? Why have you applied it in that particular way? What are the alternatives that were there for you? Which specifications have you used? Why have you used those specifications? All right. So we don't prescribe the specifications that they should be using. We say you can use a Dutch specification, you can use a Dutch code, all right? You can use an American code as long as you justify why you're using the particular code. So something as simple as designing a parking area, for example, we don't say use parking design code this and that and that. You know, Dutch code. No, we say go and find the code and tell us why you think that code is applicable. So if they want to use very large parking bays, they just need to justify why they're using those very large parking bays. So it becomes an interaction with the information that they find, within the information that is available. All right. And in some cases, there is no information available. So we say, okay, you the engineer, you tell us what information there should be, what should be in the guideline. All right. Rather than them being the recipients of the knowledge. All right. All right. So it's a very non-traditional kind of lecturing approach, very non-traditional lecturing approach, where instead of being the orator, the teacher teaching, we're getting the students to interact and with their learning, all right, to interact with the guidelines, with the codes, with the specifications, rather than just, you know, sitting there and saying, okay, tell us what to do and we'll do it. Now, that's in our view, that's not a good way of learning. It needs to be an active way of learning. So there needs to be interaction, not only with myself as a lecturer, but also with the information at their disposal.
Very interesting. Right. Very, very interesting. Yeah, and maybe one of the most important things is that you have been successful in the application of this model for several years, with challenges, of course, successful but with challenges. And then we know each other for some years, and you have told me, I remember some years ago, certain challenges, now other challenges, some challenges continued, and then you are improving. So it would be great if you can share with our audience these kind of challenges. You have success, so you have a successful model, but also there are challenges. And maybe related with the challenges is this small question, in between question. Is, you apply this from the beginning, yes? So since first year. Is that correct? You from the first years they go into the project-based learning, problem-based learning, yes? Yeah, and then maybe you can share the challenges.
Yeah. So you mentioned a very important point here, which is we apply this from the first year onwards. So there's the first challenge. Students come out of high school and they come with a certain view on learning, how they should be learning. And there's not much active learning happening at school. Students are recipients of knowledge and they have to regurgitate what they know in an exam. All right. So it's the assumption is that effective learning is taking place. So of course they come here and it's a totally different situation. Now they come and almost in the first 2-3 weeks, they realize, hold on, this is a different environment altogether. So I'm not going to be sitting there and taking notes all the time. None of the teachers are telling them whether they need to take notes or not. All right. Whether they take notes or not, it's up to them. All right. But a lot is desired of them. They have to produce, after 2 weeks, they have to produce a conceptual design. They've got to teach themselves how to use Revit or use InfraWorks or Google SketchUp. They've got to teach themselves how to find information, all right, and where to find that information, which is totally, totally different from what they were used to in high school. So this puts a lot of pressure on them and they moan about it. I often have students coming into my office and saying, but I don't know where to find the specifications. I said, well, don't come to me. All right, there's a library, there's an internet, go and look for the information. And they say, well, I don't know what I'm looking for. I say, well, that's not my problem. All right, you need to know what you're looking for. You need to take a position, you decide what you're looking for based on what you think the project needs. All right. So there's a lot of change management happening in this transition from high school to university, particularly in this problem-based or project-based learning model, all right, where we expect our students to have a certain level of independence. We expect them to be creative. We expect them to think for themselves. We expect them to be able to develop good group working skills, because the group has to manage itself. We don't manage the groups, all right? So they have to manage themselves. They have to decide amongst themselves who takes responsibility for what. And they can't at the end of 10 weeks say, but he never or she never pulled their weight, therefore we can't deliver what we're supposed to deliver. We say, well, okay, tough. All of you are going to get a 0. All right. So that transition from high school to university is a very difficult transition for them. And so they have to grow up extremely quickly. All right. They have to make sure that within that 10-week period that they're able to acclimatize very, very quickly, get used to the university's teaching and learning environment, all right, and be successful. Okay, so it is extremely, extremely tough. So that's for students, and we're mindful of that. So we have a mentor system in place. We have a support system in place that helps them, motivate them. So we have mentors, for example, PhD candidates who would act as mentors. That each PhD candidate or younger lecturers would mentor a group during the module. And so it's more of a motivational role, more of an advisory role. Hey, perhaps you need to think about, programming your project in a different way. Perhaps you need to think about doing things a little bit differently, your time management a little bit differently. So it's not that we're leaving them on their own. All right. There is a mentor system in place. We have, for the laboratory practicals, we have about between 8 and 10 student assistants who are also assisting them in the laboratories, because you can imagine you have 20 groups and they all have to do their concrete practicals or soil mechanics practicals. It's the first time ever they're working in a laboratory environment, and it's the first time ever where they're working in a project-based environment where they're given very, very little information. It's important to have enough support for them so that they can cope with some of the challenges that they face in this teaching and learning model. So that's students. On the other hand, staff or teaching staff, there are also challenges that we face with teaching staff. So in the beginning, there was lots of resistance to the Twente education model because of two things. One is people are resistant to change. So I've been teaching all the time and having an exam at the end, and that's, and in the exam, I know whether students understand the work or not. And suddenly now you throwing that, or you're putting it on its head and you're saying, no, you need to do things differently. All right. And you have to create a learning environment where students are actually learning. All right. And you have to assess the way they're learning as you go along, which means doing things differently. All right. And doing more. Because now you have to have meetings with your colleagues in preparing this design project together. You've got to have regular meetings to assess where students are in the whole process. All right. You've got to, towards the end, there's quite a bit of work getting students to tweak their design projects in the right way. Then there's the assessment at the end, this design project defense at the end, where you need to sit as a group and listen to students make their presentation. So it takes up more of your time. All right. What it also means, and this is probably one of the most difficult things, is that you cannot teach everything, so you have to let go of some things. So there are some fundamentals that you have to let go, and you have to let students find out on their own. All right? Because what we tend to do in the traditional engineering programs is that we want to teach them everything. All right? We want to teach them everything. Our view, it is not necessary to teach them everything, but if you can teach them how to learn, how to find the information, where to find the information, all right, how to interpret it, all right, then you don't have to teach them everything in mathematics, everything in structural mechanics. All right, and that's very, very difficult. It's extremely, extremely difficult for someone to let go. I too was a traditionalist previously, where I wanted to teach everything.
Yeah.
All right. You just don't have the time to teach everything. Students need time to understand what it is they're dealing with, but they also need time to understand how to apply something in practice. All right. One of the kind of, and I think this applies to all countries around the world, if you were to survey companies that students end up at, all right, most of the complaints are not about the fundamentals. Most of the complaints that companies have is that the students don't know how to work in teams. Our graduates don't know how to communicate effectively. Our graduates find difficulty applying what they've learned in universities, applying that in real world settings. All right, those are the complaints. All right, so I think from a teaching perspective, in the beginning it was very, very difficult to let go. All right, because it's very, very comfortable. I think we're in a comfort zone if you say, okay, we're going to teach for 10 weeks, and at the end we give an exam. All right, okay, and that exam I mark for 50 students. I mark the same question, I grade the same question. All right, and so I have consistency in the way that I do things. All right, but there are serious question marks around whether effective learning has taken place and whether students are able to, for example, or whether you're able to address some of the concerns that industry has around communication, around the application, etc. All right, and we think that working in this problem-based learning environment, students learn more, they discover more. All right, they interact more with the materials that you present to them, and they're working more in a real world setting. All right, that prepares them perhaps a little bit better for industry and for the real world than if you were to have a traditional kind of approach of teaching, exam. All right.
Right.
So I think, to summarize, I think there are two challenges. The challenge with the students themselves, getting the students to adapt and getting them used to this problem-based learning environment. But there's also the challenge of having our teachers adapt, having our teachers think differently, having our teachers be more innovative about teaching and learning.
Yeah. Well, when you are having fun, times fly, my friend. It's really, well, we are running out of time, and then we need to leave this for maybe another opportunity, because I have two topics left, and I will go very fast in the application of the Twente educational model on adaptation in the University of Concepcion. And then certain recommendations. I think I will write it down in the slides that I will provide for this very interesting school. We can talk about later, and then we can what is in the slide is coming from us. But very fast, I would say that we invite Sergei Miller for presentation in Chile for a workshop and a conference, and then we learn about the experience of the University of Twente. We started applying this way of teaching, and after a couple of years of success, and I mean success because we have a validation, internal validation in Chile, an external validation with Sergei, but also we asked our students, and the students said, yeah, that they like this way of teaching. So then we continue, and the result is now we have our new curriculum based, one line based in project-based learning, basically applying the principle of Twente educational model. And we experience some challenges, we are learning, but I think it's a very good approach. And then, again, I will say in the slides, and maybe some final words, Sergei, because we have 1 minute left. So then maybe some recommendations for one recommendation for application in another context. You are from South Africa, the Latin America is another context, maybe a short view of recommendation.
Well, I think my main recommendation would be, don't be scared to try. That would be my main recommendation. Don't be scared to try new approaches. The second recommendation I would have is, if you're willing to try new approaches, then start small. Start in baby steps. I think what you did, Mauricio, was good. Starting in baby steps, all right? Because you can with that baby steps, for example, let's just use your concrete as an example. So if you start in first year with a concrete design program, you could use a real world application, all right? A very small application, and then build up to, say, third year, fourth year, where you have a big application where instead of designing a base and a column, you now get students in their groups to design a small bridge or a footbridge. Are you with me? So I think baby steps, all right? And then give staff and students the opportunity to make mistakes, all right? Our students make lots of design mistakes. We cannot expect them to be rocket scientists or engineers after one module. And the same thing with our staff. We cannot expect them to get it right the first time. They're going to make mistakes. They're going to, in the beginning, lean towards this traditional model of teaching, exam, and the project, is not that important, okay? But you can see there's lots of learning that's going to be taking place, all right? Lots of learning that's going to be taking place with students and with staff. So give them both the space and the time to make mistakes. Out of that chaos in the beginning, you are going to get somewhere. Believe me, you are going to get somewhere.
Thank you very much, Sergei, for the very interesting insights. And I think it will be very useful for many professors and lecturers in Latin America. Thank you very much.
You're most welcome. Good luck with everything. Okay.
Thank you. Bye-bye.
Bye.